Welcome back. Here you see some dry ice, the solid form of carbon dioxide. Notice a couple of things. First, the two elements in the compound are carbon and oxygen from the right side of the periodic table and are therefore nonmetals. Generally, elements with only nonmetals are molecular, and they have naming rules distinct from ionic compounds, which often, but not always, contain metals and nonmetals. Second thing to notice is there are only two elements total. Such compounds are known as binary. Our job this lesson is to learn how to write the names and formulas of binary molecular compounds. There are two simple rules. Rule 1 is the nonmetal written last adopts an IDE ending. That's why in carbon dioxide, the element name oxygen was changed to oxide. The element written first, in this case carbon, is still called carbon. Rule 2 is that prefixes are used to indicate the number of atoms of each element. This is very different from ionic naming. For example, since there are two oxygens in the formula, that's why the prefix for oxide is di, which means 2. Here's the complete list of prefixes you'll need to know. Here we see di for 2. Hopefully learning these prefixes will be pretty straightforward because you're probably familiar with most of them, like tri as in triangle, penta is 5 as in the Pentagon building. You probably know that an octagon is an 8-sided figure. A decade is 10 years, hence deca is 10. Now, notice mono is 1. So you may be thinking, why doesn't it say monocarbon here? Generally, when there is no prefix, it is assumed to be mono. The only common exception to that one is carbon monoxide. Notice that the mono prefix here is included. Technically, the prefix here is only mon and not mono. Sometimes the ending vowel in the prefix is omitted when it's followed by a vowel. The main point is we usually don't include the prefix mono. So, these are the only two rules you need to know. Let's practice some by completing this table. We'll do the first row together. We see the first element is xenon, and we don't change the ending of the first element, so the name starts with xenon. The second element is fluorine, but we recall for the element written last, we change the ending to IDE, so that gives us fluoride. Finally, we need prefixes to indicate how many atoms of each. There is only one xenon, so we can leave out the mono, as we said a minute ago. And the fluoride gets a tetra prefix because there are 4 of them. That leaves us with xenon tetrafluoride. Please complete the table by filling in the remaining names and formulas as needed. Stop the video now. Here are all the answers. Let me know if you have any questions. But let me just point out one thing. Notice this last one is water. Now if you put dihydrogen oxide, I can see why, but don't do that. Some compounds have common names, and of course, everyone calls H2O water. All right, let's wrap up this lesson by completing this table where you have both binary molecular compounds from this lesson and ionic compounds from last lesson. How do you feel about that?
I quit! I've had enough.
Anyway, the first thing you need to do for each one is establish what type of compound you have. Is it molecular or is it ionic? For molecular, look for 2 nonmetals, like this one. For ionic, usually look for a metal with 1 or more nonmetals, like this one, or this one. Then once you know if it's ionic or molecular, apply the appropriate rules. I suggest you have a table of polyatomic ions handy if you haven't memorized them yet. Stop the video now and complete the table. Okay, we said before this first one is ionic, so it has these ions. The cation retains its usual name, magnesium, but the monatomic anion changes its ending to IDE, so chlorine becomes chloride. And that gives us magnesium chloride. The next one is molecular, meaning the last element ends in IDE, and we use the prefixes to indicate quantity, so that gives us sulfur dichloride. Now let me pause just a moment to comment on these last two. Notice magnesium chloride was not magnesium dichloride, even though there are 2 chlorides in the formula. For ionic compounds, it's not necessary to use the prefixes that indicate quantity because we can determine the number of atoms of each ion based on the charges. The fact that magnesium is a +2 and chloride is a -1 tells us there must be 2 chlorides for every 1 magnesium to balance the charge. For sulfur dichloride, we did need the prefix di because molecular compounds don't have ionic charges. Only the prefix tells us how many atoms of each element. Okay, these next 3 are ionic. One way to know that is they all contain a metal with nonmetals. They all also contain a polyatomic ion, so to get these names and formulas correct, you would have to know the polyatomic ion names and formulas. Let's go over the two where you were given the name and you had to supply the formula. For aluminum chlorate, aluminum is +3 because it's in group 3A. And chlorate, if you've learned your polyatomic ions, you know is ClO3 - 1. We then took this 3 and made it the subscript down here, remembering that polyatomic ions need parentheses if the subscript is anything but 1. And we took the 1 that is implied here from the -1 and made it the subscript on the aluminum. And since it's not required to show the 1, that's how you get the formula you see here. For lithium bicarbonate, lithium is +1, being from group 1A, and the bicarbonate ion is a polyatomic ion that is HCO3 - 1. You'd have to come up with that on your own. The +1 already cancels the -1, so you simply need one of each ion to give us the formula you see here. Finally, this last one has 2 nonmetals and is therefore molecular. That gives us phosphorus tribromide. Notice the prefix tri and the "ide" ending. Well, that's it for binary molecular compounds. Thanks for listening, and see you next time.